Okay, hi, so good day everyone. Today what we're going to work on is solving quadratic equations algebraically. So when you see the word algebraically and you hear me say it, there are certain things that should come to mind for you. Certain things such as balancing equations, using inverse functions. What you do to one side, you must do to the other. Those types of things. That's what we're going to start doing with quadratic equations. Now remember, what makes a quadratic equation is the square. Okay, so we're going to use the inverse of squaring a number, and so what you're going to see is a radical, okay, the square root bar. So long story short, here is some properties that we will use today. Number one, when solving quadratic equations using square roots, you can use properties of square roots to write your solution in different forms. That in different forms, that part right there, that's what we're going to address with what I'm considering as your bell ringer. We're going to practice writing our solutions in different forms. The second thing that we're going to deal with is when a radicand in a denominator of a fraction is not a perfect square. You can multiply that fraction by an appropriate form of 1 to eliminate the radical from the denominator. This process is called rationalizing a denominator. So if you're going to take a note right here, what you need to know, there cannot be a radical in the denominator. There cannot be a square root in the denominator. Now, even though we're starting to solve these algebraically, don't forget that you still know how to graph and find your solutions, which is your x-intercepts. Notice today they use the word roots. Roots is the same thing as your x-intercept. So what you see now is going to be this YouTube video. It's going to take you to, it's called a radical party. When I say square root, radical, those words I may use interchangeably. Sorry about that. Okay, apologizing up front. But you need to know how to simplify a radical. This video, although it is old, although it is something I've used for over at least 7 or 8 years now teaching, it explains the process of simplifying a radical. What I want you to notice is one thing. How does the guest at the party leave? So when you come back to this air puzzle, that's going to be your first question. How do the guests leave the party? What determines if a number leaves out of the radical or stays underneath the radical? Okay, so that's your two things that you need to watch this video to figure it out. Okay, now that you've seen the video, I want to do a little bit of practice with simplifying radicals. So I'll do 1 and 2 and you can do number 3. The square root of 32. If you watch the videos, you should know that we're about to do a factor tree. Now you can pick any two numbers that you want. I chose, when I did this, to go with 4 and 8. Okay, 4 times 8 is 32. I'm going to continue my factor tree. I know that 4 because we do our factor tree until we got primes, or like with the party, until we have a pair. Okay, so this can be written as 2 times 4. So that means I would have 2 times 2 times 2 times 2 times 2. Okay, so what happened is they left the party in pairs. The person that was left ended up in jail. So we have a 2 underneath the radical. A 2 is our radicand, and on the outside we will have 2 times 2. This can be simplified to 4 square root 2. Okay, now believe it or not, you can also put this in your calculator to check your work. It's up to you. It's up to you to choose, but you may have to simplify your radicals, and this is one way that you can do it. Okay, now for number 2, and if I'm going too fast, now is the time to take a screenshot and ask your teacher, hey, I don't understand how she did them first 2 problems. Okay, but at least watch the second problem first. All right, so the square root of 48. This can be broken down by 12 times 4. Okay. 12, two numbers that multiply to give you 12 is 3 and 4. Now, here's what I want you to notice. Technically, I can break this down into 2 times 2 and 2 times 2, and on the outside I would have a 4, much like over here. But here's the thing. If I've gotten down to 2 4s, I don't need to take that next step, okay? The 4s will be on the outside of the radical, and the 3 will be stuck underneath the radicand, okay? I just did 2 problems, kind of sort of different ways, or whatever, but the square root of 32 is equivalent, well, it's equal to, not equivalent, it's equal to the 4 square root 2, and then the square root of 48 is equal to 4 times the square root of 3. All right. Now you're up, you're going to do the square root of 147. So I want you to simplify that as best as you can. Simplified yours, which was the square root of 147. I hope you got that right. Now what we're going to focus on is the second step to what we're doing today, and that's rationalizing a denominator. Okay. What I want to do real quick is show you this is in direct relation to the second bullet point for the day. When a radicand in the denominator of a fraction is not a perfect square, you can multiply the fraction by an appropriate form of 1 to eliminate the radical from the denominator. Okay, these are the problems that we're going to do. Let me get it set up for you. What they're saying is that you can multiply this by 1. Okay, but if I multiply the square root of 2 divided by the square root of 8 by 1, I'm just going to get the same square root of 2 divided by the square root of 8. A rule with radicals is that you cannot leave a square root or a radical in a denominator. So instead of multiplying by 1, I want to multiply by 1 that would actually help me get rid of this square root in the denominator. Instead of 1, I'm going to multiply by the square root of 8 divided by the square root of 8, because anything divided by itself is 1. So that's going to be my new one. I'm gonna put a little swiggle right there. All right, so what you have here is we multiply fractions going straight across. We reviewed this, people. All right, so the square root of 2 times 8 is going to be the square root of 16. Okay, in the denominator, the square root of 8 times the square root of 8, well, that is 8. Okay, that's like the square root of 64, and the square root of 64, when you multiply those, will give you 8. Okay, so now we got something else that can be further simplified. And this is why I said early on, you got to know your timetables. All right, the square root of 16 is 4, so this can be rewritten as 4 over 8, and I hope you already see it. This is equivalent to a half. That is my final answer. Okay, that is that expression simplified as far as it can go. I can make it 0.5 or 5/10, but it's not needed. Okay, now over here on the other side with number 5. Similar thing. I can multiply by 1, but I would still end up with 3 square root 5 divided by the square root of 7. So instead, I'm going to multiply by the square root of 7 divided by the square root of 7. Okay. What's going to happen in the numerator? Well, that 3 would just get brought along for the ride. It's on the outside, leave it on the outside. 5 times 7 is 35. The square root of 7 times the square root of 7 is the square root of 49, but that's just 7. Okay, now, truthfully, if you wanted to, on the side, you can figure out what the square root of 35 is, but it's really not necessary because that would give you 5 and 7, and 5 and 7 are 2 prime numbers. So this is number 5 in its very simplest form. You cannot reduce anything else any further. Okay, so now it's up to you to do number 6. So I'm gonna pause it right here for you to try yourself. Okay, now that all those preliminary things are out the way, let's get back to what we're doing today. Now I know you probably thought, oh, I thought that was a lesson. Nope, here comes your lesson. We are solving quadratic equations algebraically. So here is what your lesson looks like Ta-da! Let's get to work. So, this is example 2. This is a continuation, like I said earlier, of solving quadratic equations. Example 1 was by graphing. Example 2 is by using square roots. Okay, so I'm going to set these up. Believe it or not, I'm actually going to try to run through A, B, and C. Okay, so give me a second to get it set up. Solve each equation using square roots. So we were given 4x squared minus 31 equals 49. That's what we were given. That's where we're going to start. Okay, so what we're trying to do is solve this for x. Now, 4x squared is just perfectly fine where it is. It's positive. Leave it alone. Okay, get rid of the negative 31. Get rid of the negatives in your life as well, okay? So the only way to get rid of this negative or minus 31 is to do the opposite or the inverse of subtracting 31, and we are going to add 31 on both sides, okay? When we do so, we will be left with 4x squared. Negative 31 plus 31 is gone. And over on the right side, we are left with 80. Okay, now 4x squared is understood to be 4 times x times x. So since that's understood to be 4 times x, we will do the inverse of timesing, or the inverse of multiplying, which would be to divide. Okay, why are we dividing? Okay, and why are we dividing by 4? You probably said so we can cancel it out. What makes sense? That's a 1 now. Okay, 4 divided by 4 is 1. So all we left with is 1 times x squared. We're in algebra 2. We're not writing no 1s. So that's x squared equals 20. We got that from dividing. The inverse, the opposite of squaring a number, has the word square in it. Here's why we did all that practice with square roots. We are going to, I'm trying to refocus. All right, we're going to take the square root of both sides. Okay, now, concept they didn't really talk to you about already. I know they didn't. When you square a number, truthfully, a negative times a negative is a positive, and a positive times a positive is a positive. So for that reason, you're about to get a new symbol, people. X can equal, here's your new symbol, a plus or minus square root 20. Okay, now, for right now, that's not even okay no more. Even though you know what x equal, guess what we got to do? Take this thing a step further. We are going to simplify our radical. Okay, that's why it says in different forms. We are going to simplify the radical, and to do so, we are going to use that infamous factor tree. All right, 2 numbers multiply and give you 20. You might have said 2 and 10. I'm going with 4 and 5 because it's my problem, and I'm doing it how I want to do it. Then 4 can be broken down to 2 times 2. We didn't do anything with the 5. We have all of our prime numbers. This is all still under the radical, okay? Because 2 times 2 times 5 is 20. But once again, how did they leave the party? In pairs. So the 2 goes on the outside, and the square root of 5 stays on the inside. But I cannot forget, it could be a positive or a negative. This is what x equals. This is my answer in a different form. Okay. Square root of 20. Okay. But 2 square root 5, better. Okay. Now, you are about to get a practice one, very similar to what you have here. Good luck. This equation by us having, this x value here, This x value, I know we just said it a minute ago, but I need you to know that this is the x-intercept on our graph. This is also our root. X-intercepts, roots. This is our solution. Why? Because you're probably saying, Miss Gabriel, why you put that S on there? Let me tell you why. Because this can be broken down to a positive 2 square root of 5. That's what x equals. And x can also equal a negative 2 square root of 5. And one more word before I forget. It's also your 0. Okay, so that's your 4 words, all representing the x-intercept. And coincidentally, since this is broken down into 2 solutions, roots, zeros, x-intercepts, what that means, hey, it's positive. That means if I was to do a little sketch right here, what that would look like, it would go through something like that. Okay, it would have to cross the x-axis in 2 places. We have 2 real roots. What are the roots? Bam, you found them. Okay, we're done with that one. Solve each equation using square roots. Here is B. Okay, we were given 3x squared plus 9 equals 0. And what we're going to do, we're still solving for x. Okay, so just like I said before, we need to get x by itself. So we need to do an inverse operation right now. You have a plus 9. So we're going to do the inverse and subtract. We're going to subtract 9 on both sides of the equation. That will leave us with 3x squared. We didn't do anything with it, so we bring it down. 9 minus 9, 0, and that equals a negative 9. Okay, now we are still solving for x. This is 3x squared, but it's understood to be 3 times x times x. So since it's 3 times x, we can do the inverse and divide. What are we dividing? We're dividing by 3. Why are we dividing by 3? Because we need x by itself. Okay. How do we get x by itself? 3 divided by 3 is 1. So we're left with x squared equals a negative 3. Okay, y'all, I had to take a pause on it because I was going to get into something that is not covered just yet. So I covered it up. I flipped up my paper. We can stop at x squared equals a negative 3. Equals a negative 3. Just forget about what I was getting into. But anyway, the square of a real number, because it cannot be negative, you can't multiply 2 negatives and get a positive. But the square of a real number, since it cannot be negative, this equation has no real solution. So if I gave you a sneak peek, then that's kind of sort of what it would look like. You would have your y and your x-axis, but this graph will never ever touch the x-axis. It just has no real solutions, and you'll deal with the other part next in a few weeks after Christmas. Okay, it's the last problem that we are going to do together for today. Solve each equation using square roots. C, we were given 2/5 times x plus 3 squared equals 5. Okay, now here's the thing. I know you don't like fractions, but in this case we kind of sort of can't get rid of it. I mean, we could. Nah. What I was thinking about was to multiply everything by 5, but then I would eventually have to divide by 2 again. So it'd be the same thing. So here's what I want to do. I'm going to use an old word to do something that I hope you remember. Reciprocal. All right. I could have wrote it in cursive so that you couldn't figure out that I can't spell too well. But if that's not how you spell reciprocal, let me know and I'll try to fix it later. But anyway, the reciprocal of 2/5 is 5/2. Okay, if I multiply 2 times 5, I get 10. 5 times 2, I get 10. 10 divided by 10 is 1. That means that is gone. So since I'm multiplying by 5/2 or dividing by 2/5, however you want to say it, I would end up with what you would have here. Okay, so over on the left side, 10 divided by 10 is 1. It's gone. It's 1 and done. Okay, we're left with x plus 3 squared. And over on the other side, another fraction. 5 times 5 halves, 25 over 2. Okay, now, here we go. Let's get some work. We need to do the opposite, because x plus 3, we can't add that. Don't you think you can add that? Because 1 don't have a variable. So instead what we're going to do is take the square root on both sides. Some gigantic square root bars. But what's going to happen over here, I'm going to be left with x plus 3. And over on the right hand side, the square root of 25 over 2. Okay, now still don't have x by itself. Okay, because right now x is being bothered or added by 3. So I'm going to do the inverse, or just the opposite, and subtract 3. I am going to subtract 3 on both sides of the equal sign. So that's going to leave me with x equals a negative 3. Where is it? Up here. When I took and did the square root of both sides, I forgot to mention that it can be a positive or a negative. So this is negative 3. That same plus or minus. Y'all don't be like Miss Gable. Don't forget your plus or minus. Okay? Jeez. All right. There you go. You can tell. Teacher's not perfect, especially not Miss Gable. All right. X equals negative 3 plus or minus the square root of 25 over 2. Now, here's the thing. This is a problem. It can't stay like that, okay? That's why we spent a little bit of time on rationalizing the denominator, because we're gonna fix this. I'm gonna put it over here so that you can see it on the same screen. So the square root of 25 over 2, give ourselves some space, can be rewritten as the square root of 25 divided by the square root of 2. That is a fact. Okay, we need to get rid of the square root in the denominator. So what's going to happen is we're going to have, I'm going to bring it over here. I wish I would have wrote this a little bit different. Square root of 25 over the square root of 2. We're going to multiply it by a 1, but a 1 that will get rid of that square root of 2. So the square root of 2 divided by the square root of 2. I don't know why I'm writing crooked. This becomes, we multiply going straight across, the square root of 50 over the square root of 4, which is just 2. This is messy, and that's okay. All right. Why am I singing a song? Well, because this square root of 50 can be broken down into 2 times 25. And if you need to see this broken down even more, 5 times 5 times that same 2. All of these are multiplying. This can be rewritten as 5 square root 2 over 2. Now, for that reason, I just simplified the square root of 25 over 2. I'm going to put that over here. Make sure you can see it. Negative 3 plus or minus 5 square root 2 divided by 2. And just like that, folks, this is your solutions, believe it or not. This has 2 real solutions. 2 real solutions. Okay, 5 square root 2 divided by 2 can be simplified by a decimal or whatever, and then you can add a negative 3 or subtract a negative 3 from it. But that plus or minus, that I don't know, I'm just writing it down real quick. Hold on. This can be written in as 2 separate solutions. So you have your plus here and your minus here. And so what this would look like in short is that you got a plus 3, so that's 3 to the left, and then that minus 5 would be down. So maybe something like this, if you were to do a quick sketch of it, the vertex would have to be at a -3 and a -5. If you don't know why, let me know. Hope you all have a great day. Sorry that this one went on so long, but I felt like with algebra, you might need a little bit of help. If not, you just got some help anyway. But if you have any questions, please don't hesitate. Let your teachers know. We are here for you. Believe it or not, we like answering questions by you. Okay? So don't be shy. Say something, okay? Remember what I told y'all, especially my kids. I'm going to need you to say something, baby. Say something. Closed mouths, once again, don't get fed. Say something. Have a great day. Bye-bye.